Hey guys, welcome back. This is going to be part 2 of interfacing my robot arm to my brain via the hacked MindFlex headset. Hey guys, welcome back. For those of you new to the channel, my name's Eric. Today we're going to go through the second part of testing my interface between the Mattel MindFlex headset and my InMoov robot arm. For anyone joining, I probably didn't explain this project real well in the past, but my vision has always been to use this InMoov arm for something it was probably never intended for, or maybe it was, I don't know. What I did is I took Gael's InMoov robot arm, 3D printed it on my Solidoodle 3D printer, installed the servos, got it all functional, it's working great. I also, at the same time, I took this MindFlex headset, which is a Mattel game. This actually is an EEG of sorts, reads brainwaves, and hacked it and sent the serial data out that I can use via Arduino. It's definitely a very cheap solution to a brain interface, probably the cheapest we could possibly come up with. My plan is to hopefully write a white paper here shortly, instruction of sort on how to, some of the things I've learned, how to go about 3D printing this. There's lots of information available online, but also at the same time cover how we can interface this. What inspired me? I saw a video once, I'll see if I can dig up the link and post it here. It was of a clinical trial of a prosthetic arm, and they had done a brain interface, and the gentleman that was training to use it was pretty much in tears because it was the first time he had ever been able to hold his wife's arm since he became paralyzed. That really struck a nerve with me that was possible now. But what really kind of got me motivated is these things. That kind of clinical stuff costs, for a prosthetic arm, hundreds of thousands of dollars currently. This is just simply not an option for most of the world. I'd say most is an understatement. We're looking at probably 99% of the world. That's just not an option. What I did is I put this together, the hacked Arduino, the Arduino board, the InMoov arm, and I'm shooting for under 100 Canadian dollars, all in, fully functional. Yes, it'll never be as good as a clinical unit, no comparison. This can be recreated anywhere in the world for a bargain basement price. Will it be the same? Never. But is it better than nothing? I like to think absolutely. Why not? Let's see where this goes. People will take the idea, make it better, improve the code, change the interface to something a heck of a lot better than $40 for the MindFlex game, and you get 2 of these headsets. The sky's the limit. There's lots of options, and let's just see how far we can push this. Anyway, that's the end of my rant and my reasoning. Let's get down to my second part of the testing. So here we are, hooked up again. Tasty tidbit for anybody who goes to build one of these. The MindFlex, it's covered in my other videos. You just use ground and the serial line. If you're changing code on the Arduino itself, modifying how the sketch works, you need to disconnect the serial data line to the headset. Otherwise, it conflicts when you're programming the Arduino. Anyway, that's just a little tip for anyone out there building one of these. So what I did, I didn't video all these. What I started doing was I modified the code to use different brainwaves as discriminators for the attention span. The attention is what's used on the MindFlex game. The more I'm concentrating, this is on my head right now, by the way, the more I'm concentrating, the higher that goes. And I wanted to set a bit of a discriminator so it wasn't just high and then low for the hand activation. The servo is still simulating what will be my robot hand interface. It's the exact same connection. What I found is simpler is better in this case. Without any training to get consistent and repeatable results, it's quite simple. It's quite simply better to use what's been done before. The discriminators didn't work out very well. It was maybe with some training it could do better, but I had a very hard time getting a consistent activation when I was trying to use the meditation or any of the others. I gave up. I went back to a very simple, if the attention is over 50%, is over 50, it's a 0 to 100 scale coming out via the serial data on the Arduino. If it's above 50, we send the output. If it's below 50, we kill the output. So I'm just doing hand open, hand close. No fancy movements here. I don't think we can get there with this headset. We just don't have the sensitivity to tell what you're thinking. This is just raw. It seems to be raw that if you're thinking hard or concentrating hard, you'll get a higher value. Anyway, long story short, I tried multiple different sketches, multiple different code, and sticking to this seems to be the best. Quite simply, if the attention spikes, we make the output happen. In my case, I'm going to be close hand. If I relax and stop talking, in this case, I'm staring at the camera. It's probably not helping. There we go. That would open hand. There seems to be a tiny bit of lag as well. At first, I could see consistent, repeatable results almost bang on, but the longer timeline, if you look at the test videos, it seems that there's quite often just a little bit of lag. I'm not sure where that is. It probably resides exclusively in the headset. It's not the Arduino output. That's wicked fast. But yeah, if you calm down and wait and stop concentrating, we can get the output to go low. And if we concentrate again really hard, we can hopefully get the output to go high, which that worked live right now. I'm getting to the conclusion that this is repeatable. Yes, it'll never be perfect for articulating a hand, but for a simple open-close movement or a grasping motion, we can do this. Yes, it will be confused by just normal brain activity like right now while I'm talking. But for the price and for the repeatability anywhere in the world on an extremely low budget, I think we're onto something. I'm really excited about this. I was pretty confident in it since day one, but now I'm starting to see repeatable results, hence the videos, why I'm showing you this live as it's on my head and the reactions. So I hope you're as excited as I am. I'm glad you could join me in this little bit of an adventure. The next video, I think we're at the point now, there's no reason I can't just hook this up to the InMoov arm, and we're going to see the same results we see on the servo here. The tricky part will be showing you what trying to control it on demand. I can't talk and tell you when I'm wanting to close or open, because that seems to mess with the brainwaves. And what I found out in my testing when I showed the videos, when I did the overlay here of the visual cues, what I found and what I didn't share is that I was anticipating. I made that video. Even though I did random time spans, I was anticipating the change of state, therefore it messes with the results. So I may have to call in a friend to give me audible cues that I have no way to know when they're coming, to share the results. I'm not sure how far I'll go there, because I think we could do a lot of training to get one's brain under somewhat of control, that we can affect the output very predictably and repeatably. You can see we seem to have some results here. Anyway, I think this video has gone on way long enough. I appreciate you joining me today. This is the second part of my robot brain interface, right now affecting a single servo. In the next video, I will show you the entire arm.